Welcome to The Explainer. Today, we are diving into a story that is shaking the absolute foundations of science. We're talking about a crisis in cosmology so deep, it suggests that everything we thought we knew about the universe, well, it just might be wrong.
You see, for decades, we've had this solid, standard model of cosmology. It's kind of been the rule book for the entire universe. But now, with powerful new observations, especially from the James Webb Space Telescope, it's looking like that foundation has some very, very serious cracks.
So let's start there. To really get what's going on, we first need to understand the official story, the cosmic rulebook that scientists have put their trust in for decades. And that rulebook has a name, the Lambda CDM model. For more than 25 years, it's been our best shot at explaining how the universe is built and how it's evolved. And you know what? It has passed almost every single test we've thrown at it, until now.
The first huge problem, the first major crack in the foundation, it all boils down to a disagreement over one single, absolutely fundamental number. Just how fast is our universe expanding right now?
And I want to be clear, this isn't some little rounding error. Nope, it's a deep, stubborn conflict that astronomers call the Hubble Tension. And all the latest data just confirms this puzzle is very real and it is not going away. Scientists basically have two gold standard ways of getting this number. The first method is to look way back in time, studying the ancient afterglow of the Big Bang itself. The other method is to look much closer to home, measuring these special pulsating stars that act like a perfect cosmic measuring tape. Here's the problem. These two rock-solid methods give us two totally different answers.
So, when we look at the light from the baby universe, the number we get is about 67 kilometers per second per megaparsec. That's just a huge unit of distance. This is the speed limit that the early universe seems to set.
But when we measure the universe around us today, we get a much faster number, around 74. It's like the modern universe is completely ignoring the speed limit set by its own past. This quote from Nobel laureate Adam Rees just perfectly captures the mood. He's basically saying, look, we've checked the numbers, we've checked the measurements. This isn't a mistake. What's left is the thrilling and kind of terrifying possibility that we've just misunderstood something fundamental about how the universe works. So, the Hubble Tension was the first big crack, but now the James Webb Space Telescope, our amazing detective out in deep space, is finding a whole lot more. It's peering back to the dawn of time, and it's finding things that, according to our rulebook, just shouldn't be there.
JWST is finding what some are literally calling universe breakers. I mean, our models say early galaxies should be these tiny, scrappy things, but we're seeing huge, mature ones that shouldn't have had time to form. We're spotting supermassive black holes that look like they just appeared overnight. It's even seen a galaxy clearing away the cosmic fog of the early universe way sooner than we thought was possible. And then there are these really weird, super bright things they've nicknamed little red dots.
So to explain some of this bizarre stuff, scientists are having to get really creative, like proposing entirely new types of objects in the cosmos. Take this black hole star idea. The theory suggests some of those little red dots aren't galaxies at all, but a whole new class of object where a black hole is eating so fast that it makes its surrounding gas cocoon glow as bright as a star. Wild. Okay, so the beginning of the universe is a total mess, but what about the end of the story? Well, it turns out our understanding of that is also being challenged thanks to new data from an instrument called DSI, and it's questioning the very nature of dark energy. The Standard Model has always assumed that dark energy is a constant, a fixed force always pushing everything apart at the same rate. But new results from DSI are hinting that it might be changing over time. This chart basically shows its pushiness. The old model said this number should never ever change, but the new data suggests that in the past, dark energy was actually more powerful, more pushy, and today it's weaker. If that's true, it could mean the universe's runaway expansion is actually starting to slow down, which would completely change its ultimate fate. So, with the beginning, the present, and the end all in question, the standard story is really starting to fall apart. So if the official explanation is wrong, what on earth could replace it? Well, scientists are now forced to consider some truly radical ideas. And these might sound like they're straight out of science fiction, but they are absolutely serious theories designed to solve the problems our current model can't handle. I mean, what if the Big Bang wasn't a beginning at all, but a bounce from a previous collapsing universe? Or, get this,
What if our entire universe was born inside a black hole that exists in another, much larger cosmos? There's even an idea floating around that dark matter had its very own separate dark Big Bang.
So, what does this all mean? It means that we are living through one of the most exciting, most pivotal moments in the entire history of science. This is a genuine revolution in how we understand the cosmos, and it's happening right now.
And this is what makes science so amazing. This isn't a failure, it's the exact opposite. This is the scientific process at its most raw and exciting. It's not about always being right, it's about figuring out where we're wrong. Every single anomaly, every broken theory is an opportunity. It's a crack where a brand new, more profound understanding of reality can finally shine through.
The investigation is far, far from over. Scientists are now eagerly waiting for the full dataset from DSI to come in. They're planning to hunt for echoes from before the Big Bang with new gravitational wave observatories. And all over the world, they're racing to build new models that can finally make sense of all this conflicting data.
And so we end with this one thought. All of this evidence, all of these puzzles, they all point to a single thrilling possibility that the universe might be far older, far stranger, and way more full of incredible surprises than we ever dared to believe. The story of everything is being rewritten right now as we speak.